how are we going to use Newton's universal law of gravitation? How do we do that? So let's look at this problem. We have the force of gravity. What is the force of gravity between the moon and the earth? So we have the moon, have the earth, and we want to know what's the force between them. Okay, so what is that force? So we need some data. We need some information about it. So we can look that information up. And let's see, we find out that the mass of the moon is 7.348 times 10 to the 22nd kilograms. And then we also can look up the mass of the earth. And the mass of the earth is 5.972 times 10 to the 24th kilograms. And then we need to know how far apart these two are. So we can find the distance from the earth to the moon. I can look that one up. 238,900 miles. Okay? So there we've got some information, and we know Newton's universal law of gravitation is the force of gravity equals capital G. Remember from the lecture, or from the presentation, that's the gravitational constant, times the mass of 1, times the mass of 2, all over r squared. So it looks like we've got everything that we need. So let's do this. Remember, G is 6.67 times 10 to the negative 11th newtons times meters squared over kilograms squared. Mass 1, let's just go with the one on the left. Let's call that the mass of the moon. So that is 7.348 times 10 to the 22nd kilograms. Mass 2, let's call that the mass of the earth. And that is 5.972 times 10 to the 24th kilograms. And then the radius, remember if we go back up there, that was 200, there we are, 238,900 miles. Okay, so we can put our stuff in our formula. So we have force of gravity equals G. That was 6.67 times 10 to the negative 11th newtons times meters squared over kilograms squared. That times mass of 1, which was the mass of the moon, right? So 7.348 times 10 to the 22nd kilograms times the mass of the earth, 5.972 times 10 to the 24th kilograms, all over 238,900 miles. And we got to square that, right? Okay, but if we look at that, hopefully you've recognized we have a little issue there, because the units on the top of our fraction, newtons, meters squared, kilograms, right? So we can't use the miles, so we're going to have to do a conversion. So let's do our conversion on our miles. Let's draw our line. We have 238,900 miles. There's our separation. So what are our conversion factors? Well, I know these. I know that 1 mile equals 1.61 kilometers. Okay, and now do we want it in kilometers? No, because our gravitational constant is in meters, so we want it in meters down here. So I also need that 1 kilometer is 1,000 meters. I know that one. So let's put our conversion factors in there. So if miles are on the top, right here, to get them to cancel out, we need 1 mile on the bottom. and that's 1.61 kilometers. And then that will get rid of our miles for us. And we need our next conversion. So kilometers on the top, so we need again kilometers on the bottom since they're on the top to cancel. And that's 1,000 meters. So those cancel and go away. So there's our conversion. So we just have stuff to multiply by on top. And that's how we get our conversion. So running it through our calculator, we get 3,846,290,000 meters. So there's our distance. So now we have it converted. We can put everything in our equation. We have all the right units. So the force of gravity equals G, remember, 6.67 times 10 to the negative 11th Newton times meter squared over kilogram squared times, see which one do we have above? We had mass of the moon first. Let's go ahead and do that again. 7.348 times 10 to the 22nd kilograms times 5.972 times 10 to the 24th kilograms all over our distance, right up there on the right, 384,629,000 meters. We're going to square that one, right? So let's come down here. Whoops, sorry. So when we multiply our top line out on that through our calculators, we get 2.9269 times 10 to the 37th. And if we look at our units, our kilograms leave us, and we're left with newtons times meters squared. And on the bottom, when we square it, we get 1.479 times 10 to the 17th meters squared. So we can see that our meter squared is going to cancel when we do that. Let's get some more space here. So our force of gravity then is going to come out in newtons, right? When we divide those two, we end up with 1.979 times 10 to the 20th newtons. So there's our force of gravity between the Earth and the moon.